so we got three functions. We got a differentiable function g right here. We got a function h right here, and then we've got f defined, so it's multiple representation. So a table, a graph, an equation. So it says let g be a differentiable function. The table above gives g, and so that's key that it's differentiable. So that means the extreme value theorem, the mean value theorem, and the intermediate value theorem all stand up. And then the rest of them talks about. So A says, find the slope of the line tangent to the graph of f at x equals pi. So all that's asking for is f prime of pi. So first we'll find f prime of x. So I'd handle the cosine, which would give me a negative sine of 2x multiplied by the derivative of the inside, so 2. And then I'd have plus cosine x e to the sine x. So anytime I take the derivative of an e, we rewrite it, then multiply by the derivative of the power. So I'm here, and then I'm interested in pi. So I'll have negative 2 sine of 2 pi plus cosine of pi times e to the sine of pi. Well, sine of 2 pi, I think unit circle back here, sine's a y, that's 0, so that's gone. Cosine of pi is a negative 1. E to the 0 is 1, so we'll get negative 1. Okay, part B says let k be the function defined by k of x equals h of f of x. And then it wants me to find k prime of pi, so I'll first find k prime of x. I've got a composite function here, not a product rule, so I'll do h prime of f of x times f prime of x. So k prime of 2 will be k prime of pi will be h prime of f of pi times f prime of pi. Okay, so f of pi, I would need to plug a pi into here, so I'd have cosine of 2 pi, which would be 1, e to 0 would be 1, so that would be 2. So I'd have h prime of 2 times f prime of pi, which I didn't write at this time, but we just did in the last part, is negative 1. So h prime of 2, if I go up here, that looks like a negative 1/3 times a negative 1, which would be 1/3. Okay, part C says, let m be the function defined by this guy here, g of the, so here. It says find m prime of 2. So first, we'll find m prime of x. So if m of x equals g of negative 2x times h prime of x, then, h of x, then m prime of x will be a product rule here. So we'll do derivative of first, which will be negative 2 times g prime of negative 2x times second plus the first times h prime of x. And so we're going to do negative 2 times g prime of, so we're doing n prime of 2. So we'll do negative 4 times h of 2 plus g of negative 4 times h prime of 2. So g prime of negative 4. So I go look here, g prime negative 4 is negative 1. So I'll get negative 2 times negative 1 is 2. Times h of 2. Well, h of 2 looks to be negative 2/3. Plus g of negative 4. G of negative 4 is 5. H prime of 2 we said was negative 1/3. So I get negative 4/3 minus 5/3, which would be negative 3. Okay, we'll go to D. D says, is there a number C on the interval negative 5 to negative 3 such that g prime of C equals negative 4? Anytime I get a question about a table, do I have to have a certain slope? I'm thinking mean value theorem. So the points of G are negative 5, 10 on this interval and negative 3, 2. If I calculate that slope, I get negative 4. So you don't have to quote mean value theorem, but by mean value theorem, since the average slope of G on the interval from negative 5 to negative 3 is negative 4, and G is differentiable, there has to be at least one place where we get this slope. So you don't have to say it in that exact words, but in some fashion you want to quote the idea. of mean value theorem, again, if we have a function who has an average slope of -4, there has to be one place where the instantaneous slope is -4. Hey, Carly. There's Carly.